So what we're going to talk about today is a little bit, I'm going to introduce something called OSCAL, and we'll kind of talk about how it is being leveraged in the coming years. This is kind of somewhere where Zero Trust was when it started, and everybody was like, what is Zero Trust and why do we need to do it? And today you are doing it. And so OSCAL is kind of at that stage right now where everybody's asking, what is this and why do we need to use this? So let's get started. So essentially what happened 3 or 4 years ago, you're all familiar with FedRAMP. So FedRAMP right now has about 350 plus commercial cloud services that are authorized, and they continue to grow that number at a pretty fast pace, and the expectation is it should go up to 3,000. Now that's not going to happen the way they're doing it today. And you got reams and reams of Word, Excel, your SSP, POEM, inventory workbook. It's just not sustainable at that rate. Post getting authorized, you have monthly ConMon, which is killing everybody. And so what happened is FedRAMP and NIST came together and started to work on a standard, and it is called OSCAL, which basically allows you to take all of your compliance information, document it in a machine-readable format. And the purpose of that is you can generate a good portion of it in an automated fashion. You can submit it via API. Imagine back in the days when you did your tax returns and you had to submit printable documents, right? These days you can just click a button and submit your tax return. That's kind of where this is going to be going. You can also validate, receivers can validate your ATO package pretty quickly in an automated fashion and kind of understand whether it's good, should I receive it, should I put human eyes on it, is it worthy of that or not? And so for the last 3-4 years, FedRAMP and NIST have been working on the standard. The first version came out about 2 years ago, and it's up to 1.1.2 now. FedRAMP is heavily invested in it, and they are going to retool their whole process using OSCAL. So what does OSCAL look like? Essentially, if you're familiar with these artifacts, you have your controls. You have your 853 or any other regulatory framework. You have your controls. Your controls need to be defined. And now these are defined in an XML JSON format, and it is published by NIST. So 853 is published by NIST, both Rev 4 and Rev 5. And from that, you are doing your tailoring, so you build your baselines. These are documented in something called profile. And so FedRAMP has published all of their profiles in OSCAL format. NIST has published the FISMA profiles. We understand the Australian government is publishing their control set requirements as well. And there are projects in Europe underway right now looking to see in the financial industry how this can be applied. So now you have your control definitions, which we can automatically import. You have your baselines that we can automatically import, and they can tailor your requirements pretty quickly. And from that, you can start building out your SSP. And what that really means is you already know exactly what controls you need to comply with, and your technical infrastructure, particularly in the cloud world, we can start populating your SSP based on a lot of the components that you're inheriting or you're leveraging. So everything that you're inheriting, if anybody's worked in CSAM or Exacta or Archer, you got to sit down and inherit control by control by control. And what happens now is just by specifying what services you're leveraging, where you're deploying, we can automate all of that control inheritance immediately. And once that document is produced, it feeds data down into the SAP. And as you're running your scans and you're populating your findings, they can be automatically populated into the SAR. And once you build your POEM out of the residual, that can be managed and maintained automatically as well. So there's a lot of automation that is going to be coming into this space, both for document generation as well as for processing and assessing the systems as well. So what is this going to look like when it is done? There we go. Thank you. All right. Thank you so much. All right, so what is this going to look like when it is done? Essentially, particularly in the cloud network, right? When you have cloud-based systems, you have your IaaS that you're leveraging, right? Which is AWS or Azure or GCP. And you have a lot of controls that you can inherit from. the cloud, particularly physical security and a lot of the other sectors. So you have IaaS that is being built, and this is now FedRAMP authorized. Then from that IaaS, you have a lot of PaaS out there, like ServiceNow, Salesforce, and a lot of the others. And so they're inheriting from the IaaS. And then you have your SaaS applications that could be built directly on IaaS, or it could be built on PaaS, that are also inheriting from all of these. And finally, you have your final application that is being leveraged within your organization, so you have to put it through your own security assessment as well. Now, what's happening on the other side is you have your app devs that are building applications on top of all of these platforms, and so you're inheriting controls from these platforms as well. You have regulatory frameworks that are publishing all of the controls on a regular basis, the requirements, what they need to see in order to authorize the system. So a lot of information has to exchange between a lot of different parties. Finally, you're going to be running your assessments. And as you're running your assessments on policy management or assessment tools, you're bringing back vulnerabilities. Vulnerabilities need to be converted into risk, and you have to understand your risk posture. All of this data interchange is kind of happening in separate pockets. Some of it is in Word, some is in Excel, some is automated, some is not. And the future is going to look like everything will be integrated through a single data representation, and that is going to be OSCAL. And that's how everybody can publish, correlate data, consume data, and you can have the entire pipeline working. So what we have been working for the last 3 years, we have built out all of the regulatory controls in OSCAL. We have the control inheritance working at this point. We have all of the authorizing officials and the app devs material that needs to be done. And we're at the point that we're now starting to automatically process scan files, automatically look at vulnerabilities. So when you have a vulnerability, you got to figure out what does this mean, right? So remember Log4j? Yes, everybody does. So when Log4j happened, the first question that everybody asked was, where are we using it? How long did it take to answer that first question? It took a long time because you just don't know where you're using it, right? Okay, after we got this spreadsheet done that said, here's all the systems that we know are using it, then the question becomes, you got to prioritize. Which are you going to fix first? And that depends upon where does it sit in your network architecture, right? You got to use that context to figure out which is priority and which is not, which is getting to the risk score. If it's all the way in the back end, it's probably not high priority. If it's in the DMZ or somewhere closer to the public network, then you do need to get to it pretty quickly. And so how does that prioritization take place? So what we have also been working on is, like we said, automating compliance documentation, automating assessments, automatically processing vulnerabilities, and then let's see how we can bring in these vulnerabilities and assess them in context of architecture and be able to determine the score. So we leveraged machine learning for that. And so we trained a classification model. And what we did is we brought in a few features for that model. We brought in description of weakness, the source that found the vulnerability, the asset ID, which kind of gives us a proxy of where does this asset sit in the architecture, the weakness, specifically what we found, and kind of from a historical standpoint, when did we find this vulnerability. Based on these 5 features, we trained a classification model, and we tried to see if we could determine the risk score as a human would have determined it. And we found that we were able to predict the risk score with 95% accuracy because of all of the features that we have pulled into that. What that allows us to do is you can now go from scan all the way to risk in an automated fashion without manual intervention. Once you get to the risk and you understand what your risk looks like, you're then going to start prioritizing your mitigation strategy. And if you have predetermined mitigation strategies for different kinds of risks, you can automatically kick them off as well. For example, opening trouble tickets, initiating Zoom calls, putting some tasks together, assigning things, so you can literally go from scan to mitigation activity in an automated fashion. And that's kind of where we want to get to in the near future. Now, what happens is your vulnerabilities morph, your threats are changing. And so in order to stay current for this model, what we had to ensure was that the machine learning model was getting retrained on a regular basis. And so we tried a few different things, and what worked best was a sliding window model, which basically means you're looking at your last 100 risks, you have trained your model based on that, and after a certain number of new risks that show up, we shift the window, we drop the old 10, add another 10, retrain the model. And by retraining the model, you're keeping the model current as to situational awareness of what is going on right now. If you end up re-platforming the entire application, you would probably have to start over again. But that's kind of the extent at which automation can work and automation will bring you to. So with the sliding window, what we essentially did is, you have your first training, you have your first slide, second slide, and what we're doing through this entire process really is that we are training the model on your first sets, and then after 15, 20, whatever your window size is, you're going to slide over, retrain the model, and we try to test the model to see if we can still correctly predict risk scores. And if you look at your risks, majority of them are moderate. Very rarely you'll have a high, and you do have a very quick turnaround time for high. You have very few low. Majority of your window sits in the moderate space. And so the accuracy of predicting moderate is pretty decent from that perspective. The other problem in the cloud space is that your inventory is changing frequently, right? If you are platform cloud native, if this was lift and shift, you probably have dedicated EC2 stacks, your inventory is not changing. If your inventory is not changing, then your model is also staying pretty stagnant. What happens with cloud is if you are dynamically spawning containers and you're dynamically spawning inventory at all times, the model is going to have to retrain and respond to that as well. But that's kind of the nature of what you have. And that's what's changing the scape in the market also is when you have a fixed asset, a lot of the organizations are still conducting their compliance from a fixed asset mentality. You don't authorize an application, you authorize a stack. And you have multiple applications running on the stack. So the thinking process still is, I got a rack, I got to authorize the rack, and everything that's running on the rack is automatically authorized because I bolted down the rack. That's not how it works in the cloud space. In the cloud space, the services are operating, God knows on what kind of racks, and you're leveraging those services, and you've built your application to be cloud native, which basically means that you now are going to be authorizing application first, because the underlying services are already authorized. And so there is a huge mentality shift that is going to take place. The old RMF process talks about collect your inventory first, and you start your compliance process from inventory first. The way the world is going to change is you have to start application first. You have to understand your application, you have to understand the services your application is using. Inventory is a byproduct in the sense that this is kind of where everything is running, but you do have to make sure that your application is certified first. And that shift basically means you cannot just, scan a stack and say the stack is good and I'm good. It just doesn't work like that anymore. Particularly if you're containerized. Your containers are going to be spinning up, on a singular basis, and you have to scan every container on an ongoing basis, right? And so what is also going to happen is the old model of I'm going to scan this every 6 months, or I'm going to scan this every 3 months, or I'm going to scan this 1 month. You're still taking a snapshot view. And the snapshot view was fantastic when you had fixed assets. You do not have fixed assets in the cloud world, which means you've got to bring scanning into the CI/CD pipeline. So how do you do all of that? How do you come into the CI/CD pipeline? How do you do compliance checks in the CI/CD pipeline? Not just security checks, but compliance checks. And you find a vulnerability and the CISO wants to know, what does it mean? What does it mean? Like, okay, you found something, a configuration changed on the container, some ports got opened that shouldn't have been opened. What does it mean end of the day? Are we going to let it go? Are we going to block the container? What are we going to do? Those decisions are risk-based decisions. And today, that risk is extrapolated, manually, and somebody that's smart makes a decision. But you can really take this down to the point you can compute it on an ongoing basis, set your policies down, set your water lines, and you can automatically make a decision whether a container goes out or not at that point. And so that's kind of where the thinking is going, and it's going to be changing. So from that perspective, you need a platform that is going to be comprehensive. Comprehensive in the sense you can take your documentation all the way from control definition, all the way to POEM and risk management. You need a flow of data pipeline, and you got to make sure that everything can flow in an automated fashion. And so OSCAL is the standard that is being developed to meet that requirement. FedRAMP is the #1 adopter. We're seeing that adoption starting in other government agencies as well, particularly with DoD and slowly going into the FedCiv space as well. Anybody's heard of Platform One? Yes. Okay, so Platform One is the factory project that DoD is undergoing. CMS is going through Batcave. There's a lot of initiatives like that that are in place. They're embedding OSCAL as the standard on how compliance information is going to be generated, studied, processed, and adjudicated on. Okay. So we have built a GRC platform that kind of does everything that CSAM, EMAS, Exactar, Archer, all of these do, but it is built ground up on OSCAL as the data fabric, and it leverages everything that OSCAL supports and does. That's it. Any questions? Yes, sir.
When you were talking about the accuracy on your machine learning, do you also provide like a confidence on that?
Yes. Yes, it automatically, because it's classification model, the classification model always gives you the answer and a confidence factor on the answer. And we allow the user to decide whether this is something you want to accept or you want to reject. And if you reject it, it will get fed into the retraining in the next Windows slide. So we immediately learn from that. So yes, that does happen automatically. Any other questions? Nope. All right, that's it. Thank you very much. I appreciate your time.